and excited to have Paul here to talk a little bit about some of his interests and to go deeper with Pandas and Jupyter. Close enough. Jupyter is my daughter's name. Very close. Before we get kicked off, though, I just want to introduce a little, for you folks who've never been hands-on, a little bit more about who we are and what we do. Is it on? I don't know. It's kind of on and
now it's on.
Now it's on. Now it feels great. So, for those of you who know, it depends on the kind of work that we do, and we are as an organization, so that we stop stealing all Paul's time. Canvas is a third-party consulting and professional services firm. We build custom software for large organizations and help them do things that their own teams don't yet have the skills to do. That can be a lot of different things, but usually front end, back end, and in the cloud. Beyond that, folks like what they see and like what they hear. Please come back. We do this on a monthly basis. And we have a couple open roles, so if you like what you see and enjoy some of the conversation, please feel free to reach out. Cool. Thanks all for coming. Paul.
Thank you. Thank you very much. I never had one. Well, thanks everyone for joining us. I was here a few months ago and mentioned to Carlos that I was doing a fair amount of work with Jupyter, and he said, that sounds like something that some of the folks might be interested in. So here I am a few months later to give you guys an introduction to some of this. We're going to have a discussion at the beginning, or just kind of an introduction and a discussion of how the pieces are put together. Then we'll have a brief break, and then I will actually kind of get on the keyboard, and hopefully what comes out will be what I expect to come out as we went through a couple of things. So, and then if there's time, you can do Stump the Chump and see if anybody can ask me a question I can't answer. That might be a short session, but so anyway, we'll start here. I work for Virgin Pulse. I've been with Virgin Pulse about 6 months probably. I was working for a small company in Coventry that was acquired by Virgin Pulse. And I am now working, most of my work is involved with migrating our clients from the old world to the new world, if you will. Virgin Pulse does wellness management programs in an effort to help get people healthy and inspired. And also there's a lot of compensation structured in it in terms of direct deposits into HSAs, and I have built up since I got there. I think I have $160 now on my that I will have a card, an Amazon card that I can spend based on my sleeping well and I don't know what else I've done, but I've done the sleeping part.
You get paid sleeping?
So I like to think of myself as an early adopter. I kind of like look out at the horizon and things that are new and interesting. I like to jump in on. The gray hair is not fake. I did actually have, when I was in high school, we had a PDP-8, which was a very early and significant mini computer, and a teletype right next to it. And it served about a half a dozen schools around. I grew up in Marlboro, which is we're about 6 miles from digital. And I actually did flip the switches on the front of the machine, where you would have to kind of bootstrap so that it would be able to talk to the teletype, so you could feed a ticker tape through and actually boot the machine. So that was my early stuff. And I have done Raspberry Pi stuff too, so I'm still kind of staying active. I've done mostly a lot of database work. I work for a business that did, we built a large application to support litigation review, document review and litigation. And I built and managed the team and the tools that we used to actually push all the data into the system. So that's kind of what I've done in the past, and I think the last bullet is part of the reason I'm here. I like to evangelize about things that I find to be cool, and hopefully others agree and I'm right. And I think I am here today. This stuff is for real, and it's going to be here for a long time. So Jupyter is actually, it's a lot of things, but it's an environment that allows you to tell a story, and it allows you to have provenance to the story. So Jupyter is really an interface to your calculations and to your data. I don't want to sort of read off the slides here, this would be boring all of us, but these are the basic concepts that I think make it attractive. I'm going to show you a few of these because these are done by professionals, real professionals, not, probably more skilled and learned than me and in my work. But I will just show you a few of these, if I can find my mouse. Let's see. This particular one I found on a blog, and this guy's actually kind of interesting. He's a mathematician, and he blogs quite regularly on kind of simple concepts and breaks them down and helps you understand the math and the investigation behind it. Here he's investigating why is it that when a bus comes every 10 minutes, why is it always 10 or 11 minutes for the bus to show up when we get there? And he is actually developing here. I should point out that this is served up by Jupyter, by an NV viewer at Jupyter, and we've just passed it a path to a public path to a notebook, a Jupyter notebook. So this is actually sitting on GitHub and is being served up to us by the NV viewer at Jupyter.org. So this is his presentation, essentially his paper. Markdown, he uses Markdown. We'll see a little bit of that. We use Markdown to format the paragraphs here. Here's some of his code in here. You can see the part of the REPL here. This is our input. This is the output. And using the various things that Jupyter supports, like math, symbols, plots, and this essentially tells his story and does his proof, and he teaches you why the bus doesn't on average come every 5 minutes, even though it's scheduled to come it's scheduled to come every 10 minutes. You'd think that half the time, that it would be there in 5 minutes, but it's not. It actually takes 10 minutes for a bus that arrives 10 minutes on average when you show up. So that's the story here. The other one I wanted to just point out briefly was from the Los Angeles Times. Whoops. Sorry. The LA Times has done a lot of stuff. They've got a nice repo. And this particular one we're serving up a little bit differently. This is directly, I went out to GitHub here. GitHub knows now, I think as of early this year, knows how to serve up Jupyter notebooks. So this is a notebook that's actually sitting on GitHub and is viewed through the GitHub viewer. And this is an article that was in the Los Angeles Times that is referenced. It says, basically, here's the data and here's the analysis that we've done to behind the information that's in this article. So this is how the LA Times is using it to back up some of their articles and explain to people exactly what kinds of analysis they've done. Let's see, what do we got here? Okay, so I'm going to talk further as well about Pandas. And Pandas is essentially Excel on steroids. I started using Python, and I was doing a lot of work with CSV files, and I was looking around for CSV importers, and I discovered Pandas and then said, wow, this is, I don't know how I missed this. It's an extraordinarily powerful tabular, kind of programmable Excel. And of course, you're driving it all from code. This essentially means that instead of 17 mouse clicks and drags and drops, etc., taking you from your start to your finish, and no one knows what happened in between, everything that Pandas does is defined by code. And coupled with a notebook, it really makes a presentation, a nice presentation piece, but not just you know, for the code and the data and the results, so that folks can really understand exactly what's gone on. These are some of the bullet points on Pandas. It actually comes out of a guy named Wes McKinney, who is a finance guy. So Jupyter is being used, and this first one is interesting. Paul Romer, who won the Nobel Prize for Economics very recently, has become a real proponent of Jupyter and, by extension, open source. He's had some interesting comments recently about using Mathematica versus using open source tools and Jupyter Notebook specifically to publish his data. He's also kind of taken on one of the mantras of Jupyter, and that is that it really is the way in which research papers should back their data. Instead of having you know, in the old days you'd have a paper and it would have some graphing and tell you about some calculations. Published in a notebook, it's all there. Everything is there in front of you. So anyone who wants to reproduce the experiment has all of the tools that they need to generate from soup to nuts. I mentioned journalists and journalism. Big tool for data scientists, as kind of alongside R. There's a lot of parallels with R and similarities. So let's start now talking a little bit more about Jupyter and how this is put together. There's kind of three pieces to Jupyter, which, by the way, gets its name from Julia and Python and R. Julia and R being, well, all three of them being represented here as kernel mode, the kernel, I shouldn't say kernel mode, but as kernels. Kernels are custom-built extensions of lots of things. There's one for Bash, there's Perl, there's basically anything that has a kind of a REPL. If it is understands how to talk using 0MQ to the notebook server, it becomes Jupyter compliant at that point. So the kernel talks through 0MQ to the server, and the server, the server actually communicates to the browser, and those are the pieces that are put together. So when I'm at the browser and I type something into the browser, the notebook server sends it down through the message queue to kernel, and the kernel responds back, and the output comes back to the browser. And that's basically how they're put together, but it's all modular, and there are many, many kernels. I'm going to say that there are probably 50 or more kernels here, Haskell kernel, but the prominent ones seem to be Julia and R and Python. So let's see, what do we got? Jupyter has extensions too, and I'm not actually using today the latest Jupyter, which is Jupyter Notebook, a multi-tabbed kind of interface. It's got a few more tools. It's a little bit immature, although they're recommending that people use it. I decided to stick with the tried and true Notebook, which is, the kind of earlier version of Jupyter. So I just listed here a couple of extensions just to kind of describe the sort of things that you can do. Snippets allows you to build essentially a JSON file of code snippets. You drop down from the extension, you have a list of your snippets, and it'll just pluck them out and drop them in the notebook for you. Freeze is a method to actually protect the cells, so that you can actually set some of your notebook cells. And this is something when you it's very easy to go back and tweak something. I found it very easy to go back and tweak something and then tweak it sometimes in a way that it doesn't work the way it did before. And so sometimes it makes you, if you freeze the cell, then you would force yourself to kind of copy that cell out and start over somewhere else. So that's the kind of stuff that freeze is designed up for. And traceback skip traceback is folding error messages. Some of the error messages come out, they come out basically from the standard Python error message, and they can become verbose, And if all you're concerned about is the fact that your piece of, the error message and not the trace, this allows you to stop the traces that come out. So these are just a few examples of things that are part of this ecosystem and add-ons. NB Viewer, I think I showed you a little bit. NB Viewer, NB Viewer as a notebook viewer. You point if you have a publicly available notebook, you can allow anybody to view it just by telling them, go to NB Viewer and stack and just put my path on the end of the NB Viewer URL, and it'll serve up that Jupyter notebook. Jupyter Lab I referred to a little bit earlier, multi-tabbed interface, much improved interaction with the user, dragging and dropping cells around and things of that nature. So that really is kind of worth the price of admission to move over. And I actually do my daily work using Jupyter Lab, although I stuck with the notebook for here tonight. Jupyter Hub is a mechanism of kind of using teaching environments, allows multiple people to share a notebook. Papermill turns out, I think is going to be a very important tool. And I'll refer to these a little bit later. I think I put references in here. Netflix really seems to have taken this on in a big way. And one of the things that Netflix has done is supported or perhaps even built this tool called Papermill. And Papermill is used for parameterizing and executing the notebook. So and I really strongly encourage you, if you're interested in this, to read the blogs from Netflix. They're describing essentially scaling this up into a I don't know exactly how to describe it, but scaling up the notebook operations in a big way. They have built these parameterized notebooks. The notebooks themselves have configuration information, like resource demands in them. So when you make a notebook, it will run in a standard configuration, but if the analysis requires more hardware than that, they've got a tool right within the notebook where you would build out the configuration. You pass it to Papermill. Papermill will open the notebook, build the machines to run it on, run the notebook, tear down the machines, and finish with the result. So, and they're doing this, and they're doing some big, huge analysis that they will run like quarterly, and they just have to push a button and it builds up a machine and builds up dozens of machines and runs a thing, and 6 hours later it tears it all down, and the job is done for the quarter. So what they're doing is they're having their kind of data analysts build these notebooks and then allow business analysts to provide parameters, to drive them by parameterizing them. So the business people will get a notebook and they can put in a region and various other things at the beginning, and the analysis will build the machines, run and produce the result back to the user. There's some detail too about they actually template the notebooks, so each notebook is run and is essentially memorializes the analysis. They talked about troubleshooting, because when troubleshooting, you get everything in front of you. When something happens, you got everything in front of you to do the troubleshooting. You don't have to worry about reproducing the environment that drove it. So that's very interesting stuff. And that's sort of the summary of the kind of overview of the system. This next slide is talking about some of the stuff that I have actually put together to help us kind of mostly see Pandas in action. But maybe if there any questions about the environment here and what we've discussed so far? What's your name?
John.
John.
So I think that they're super cool, Jupyter notebooks. One of the challenges I had playing around with them is like, how do you connect that to like, in your little schema, right? You have there's the notebook server, which is loading the notebook file, presenting it to the browser, which is presenting it to the user. But clearly Netflix is doing something where they're using this as like a very key part of their reporting that's actually the data I'm going to be playing with in the frame, rather than loading it from a file. What will they say? Because that for me that sort of ends up being a limiting reagent. Like, I want to pull from some API. I want to pull from this database. I want to.
Well, interesting you say that because as I went through this and I got to the end and I said to myself, this is the real world.
Indeed.
And I actually have some stuff that I have put together that I use daily for Salesforce. So you use Salesforce API. So that's just essentially whatever Python can do. So whatever Python can do.
So you're written that adapter in Python to go talk to some REST API site.
That's correct. That's correct. Yeah. And so in Python, the significant tools are SQL Alchemy. I don't know how familiar you folks are with Python, but SQL Alchemy is they call it a database toolkit. The guy who built it wants to call it a database toolkit, but it's essentially an object relational mapper for Python to talk to many SQL backends. So once you've done that, you can now use, and you can talk directly, so you can talk direct SQL, or you can build objects in Python that map to the structures of the database. And once you've done that, you're just talking, to SQL Alchemy, and it's just talking to the database and doing whatever it has to do to pull the data in from the database.
Right. My dream would be that there would be some active record equivalent, though. In reality, I realize Ruby's not like a well supported part of the community for this.
Well, you should read about SQL Alchemy, because SQL Alchemy is not active record. It's a unit of work mechanism. It's a different thought, different process but it's extremely powerful.
Cool.
But the other thing is you can just use a Ruby kernel instead.
Well, right, but then what the community support would be for plugging it in, I don't know. But
yeah,
I'm sure you could do it.
And I haven't really studied this extensively, but it seems to me that once the messaging part of it is done, that
in principle,
it's pretty much intact.
Right?
Because you're really just talking to, essentially building a shell around Ruby, and then just talking to the shell.
Right.
So I don't know, but there are some fundamentals of the architecture of these things, some of which lend themselves extremely well to being ported into a kernel, and others that don't. And I can't tell you, unfortunately, exactly what those differences are. But I can tell you that using Python, and I'll show you some of this, using Python to, some of the code I use, I pulled off of GitHub, something called Simple Salesforce, which is essentially an abstraction, and I'm just talking directly in their special query language, but I just talk directly to the thing, and it answers me back and brings me back and stuff.
Got it.
Is that getting your point?
Yeah. I mean, it sounds like you can use it in these sort of real world live open network environments and figure out, sort of think about your adapters yourself and think about what makes sense.
Yeah, I mean, I think what it comes down to is when you get a kernel, whatever the kernel can talk to, you can push it back up.
Right.
The other thing is that those boxes, the browser, the server, and the kernels, they can be over different machines.
Right. Yes, that's right. They're all talking through message queues and or standard HTTP. So I don't know, Carlos, you want to take a break here?
Take a break, and then we come back to the demo, right?
Yeah. We'll see some of the stuff in action.
Yeah, 10 minutes break.
Yep, I'm ready. All right, so I'm telling you this because it's good for people to know where you get the data, and I think it's kind of cool that they have this stuff. So here I go with my little pitch on this. Retrosheet.org has been assembling baseball data. They've got baseball data. They've got baseball data all the way back. I don't know if any of you guys are baseball fans, but if you're baseball fans and you like numbers, Retrosheet is unbelievable. What I have here that I'm using is this, what they call an event file. An event file describes essentially the game situation, and then an event might be a runner moving up, a pass ball, any kind of event in which the situation of the game changes from the prior pitch is recorded as an event. I calculated about 79 events per game for 2017, and actually, the data in Retrosheet's kind of funny. It almost looks like it's been around way before this, but it almost looks like it wants to be JSON because it's fielded stuff, just basically in a single column, like key value kind of arranged. And so this Chadwick stuff has been around for quite a few years. I went out and I grabbed the source for this Chadwick and built these executables that we'll be running, and they take that kind of form-based data and make a tabular data set out of it. So what? Let's see. I think I have a couple of things. These are the things that we're gonna cover. I'll be showing you interactions, importing rather the Pandas, the series, the data frame, the index, which are the key things here. Poking around to sort of look at your data and understand your data. Restricting data sets. Filters, what I call filters, querying the data frame, merging data sets, grouping and aggregation. This is the stuff that I use. I'm on Pandas I'm on Python 3.7 here. As long as you're on 3.6, any and all of this stuff should work. This is the latest Pandas, Jupyter. This is not the latest IPython. They just came out with a 7, but I broke many things for me, so I went back. And then I use something also called Cookie Cutter, which is quite cool. And Cookie Cutter just is essentially a script that builds a directory structure. So whenever I start a project, I just run Cookie Cutter. I get a directory tree that enables me to store code and store raw data, input data, output data. So I've been working off of these directory trees. This is not a critical part of what I'm doing. But if you're going to set up an environment to do this, I think it's a nice, it's a real good piece that allows you to have a consistent structure to all your projects. Okay, so here we go. Let's see. We got some of the things that I will show you. Let's see if we can make this. Let's see. Okay. I'll describe the environment while I'm in here as well and some of the things that I'm doing, but the first thing I'm going to come in here is I'm going to take all output and clear all output from the sheet. So where we used to have an input and an output, I've thrown away all the outputs. So now we can go here and run actually these interactive commands. And let's see if I'm start off here. These are my imports from supported libraries that I'll be using. There aren't many here that we'll be using. The percent and double percent are Python magics, IPython magics, and they allow you to, how should I put this? They're tools, kind of tools-based things. So like for instance, this history is my history file of all the commands that I've typed since this kernel has been running. So this is accessible to me. I can go in here and search this, et cetera, et cetera. The bang here enables me to connect to the shell to run a shell command. So I run a single shell command that does a listing of this directory. And by the way, this will allow tab completion out, so it's talking actively to my shell and enables tab completion in here. I'll show you more tab completion stuff as we go along. This is the Bang Bang SH allows me to actually have a shell into which I can send multiple commands. And so let's just close this down here. And I'm not even sure what these commands are going to do, but I've just done, these are just a few examples of the fact that you can actually run a set of commands in the shell and get your output here. Let's see. Interacting with the shell is kind of neat here because all I have to do is do a variable assignment to a shell command, and the output for the shell command will drop into the variable here. So when I run this, I have made now a list of the files that are returned in that ls call. And this is a special kind of object called an slist object. It's an IPython object, and it allows you to do things like grep the output, grep the set. So when you issue a command and you get back, it comes into this slist object, and this slist object, very much like a Python list, which is just an array, but it's got some special characteristics on it, like you can grep the output. You can create these that I've never used, but these are POSIX file objects. So these are some of the added utilities that IPython has put on. Anybody who uses Python, you should really, really look at IPython for doing kind of casual REPL stuff. It's really, really nice. And essentially, all the things that you'll see me doing when I do tab completions, et cetera, they can all be done without an notebook environment, without a browser environment, talking directly to IPython. So let's see. And this is I think obvious. I think it's way more powerful. I'm going to actually set a variable here to this string. Is this big enough to? Should I make this a little larger?
Yes.
Let's see if I can figure out how to do that. How come I didn't see? Okay, here we go. So here I'm going to actually just set this string into the variable called extension. And if I do an ls, it's going to tell me it can't find anything because I have no files named star. And in the brackets, I'm sorry, I skipped an important point. The brackets expand the variable. So I'm issuing a shell command here, ls, and I'm expanding the variable that's stored in extension and sending it out to the shell. And it's telling me there are no IPYNBB files. So I've typed this wrong intentionally. And because I wanted to show that you can actually, within these brackets now, I can actually do, this would just be a Python command of dealing with a string. A string in Python is a list of characters, essentially. And so what I'm doing here is saying, give me the list from 0 to the n-1 characters, where n is the length of the string. So I'm chopping the last character off the string. But what I really want to show is that I'm doing it within these sets of braces, and I'm able to pass the output from that command out to the shell. And there I get the notebooks that end in IPYNB that are in this directory here. Incidentally, all these things that are in this directory will be on GitHub. So if you want to see any of this stuff, you can pick it up from my GitHub repository, which is in here, but it's PRODG 1974, if you want to jot it down. And you'll find there's a Jupyter intro repo there in which all of this information and data reside. Okay, so what I'm going to do now, I'm going to use some of the techniques I just showed earlier, and I'm actually going to run. We're going to take a look at these files, and let's just make a link. So and it's making a link, and it's telling me the link is already there. So this should work. So let's run. So here we're going to actually run this CW event, this compile program, against an event file, and I am going to take essentially I'm building a header here. I'm just going to take the first line of this output and put it into a @bats file. So that seemed to work. And now I'm going to actually run a loop here, and this loop is going to get the list of all of these event files, and it's going to run CW event with each of those files and then append them to this file. And then it's going to actually do a little another set of data right behind it there on the second line. It's just going to string some files together. So let's see what happens. The asterisk here is telling me that something's running, and here's the output from the command. I couldn't get the command to stop shouting out to stand. I assume this is going to standard error because it's got a pink dialog background here, but there is no error. I don't know why it's going to standard error, but it worked. So I stopped arguing with it at that point, and we moved on. So now what I've got is a giant file with those 191,000 records in it that I referred to earlier. Let's see, in this technique here, I'm actually just creating a Python dictionary out of a file. This is a 2-column file, and I'm just going to open the file, loop through the file, and create a dictionary lookup for these event codes. So let's see what we get here. Whoops. I'm going to back up here because I just did something that I probably should have told you folks about a long time ago. When I hit enter here, I change essentially from command mode to edit mode, and I come in and I'm in an edit mode in this cell. And you'll notice that this drop down here is markdown, showing me that this is actually a markdown cell. So in this cell, I can put any standard markdown code, and the server will render it and send it back to the browser when I execute this cell. And that's what you saw when we looked at that article earlier that was nicely written. Those are cells, so we could have opened those cells up too and seen his markdown that resulted in the output that's displayed. So we loop through, we build this event code set, and here's what it looks like. So these are the event codes. One of the columns in my file is an event code, and it describes the various things that might have happened on the field. They are described numerically in the file. So I made this up myself basically. This is just a key value dictionary here for all of these event codes. So when I go in and look at the event column, I can look for other events instead of 12, or I can look for stolen base instead of 4. You'll see me using this a little bit as we go on. But the point here is a little bit of a Python point, and that is looping through a file to build a dictionary. So that's just what I'm trying to show you a little bit of here. And here in these two are actually, this is the first time we've seen Pandas. And we're going to create this data frame called events by using the read CSV mechanism in Pandas. And it's going to create a data frame, 2 data frames from each of those sources. So let's run those. So now that we have our data in a Pandas data frame, it's time to figure out what the heck we got. So here are a few things that I generally use to help me understand what I have. The first of them being the shape. So this tells me this is the shape of the data frame. So my events data frame has 191,196 rows and 36 columns. And the columns property of the events events data frame returns this index object that is the name of the columns. So these are all the column names, the 36 column names that are in the data set that I just loaded from this 191,000 line text file that we just built from rolling through all of those event files and stringing them all together, converting them and stringing them all together. So these are the columns. So this tells me what the header of the file is, essentially. This is the head command from the data frame that shows you the first 5 rows by default of the data frame. You'll notice the ellipsis here, as it's not showing me 36 columns here. It's showing me some, I don't know how it makes it. But it's actually, there's a setting that I can use to control how it displays these. So there is an environment setting that I can use to control this. The info method here gives you a summary of information that's in the data frame by column. So this, again, these are pandas commands, right? This is pandas info, dataframe.info. Tells me this column game ID has 191,000 non-null objects. These are integer columns. Objects are strings. Essentially, objects are strings in this. You can think of objects as strings here. And this is the various overview of the columns of data. Let's see, what do we got next here? Really having problems finding my mouse here occasionally. So let's see, we've gone through the events. And there's also a describe that actually does an analysis of the data that's in the columns. Most of the data that we have is not applicable. It's coded data as opposed to kind of, what do I want to say, cardinal data, if you will. So it doesn't really make much sense to do a mean of the home batter ID, but this is just a tool to help you understand the data that you have in your data frame. So now I'm going to show how we actually start accessing data within the data frame. I'm going to restrict from the 36 columns down to a single column. Then I'll show you how to do a set of columns. And we'll do a few more steps as well. So here we have again, where I'm using the head. I'm using head on a lot of these, so we don't return all the rows. If we return all the rows, we'll get the same ellipsis thing. We'll get 60 rows out and ellipsis. First 60 rows and ellipsis in the last 60 rows. But so here I'm actually saying I'm interested in this data frame, the F events, and I'm interested in this particular column of the data frame. So this is going to return for me this is actually what we call a pandas series, which is a single column. Its name is the title of the column, and here's the zero-based index that Pandas provides for all of its, as a standard for all of its. I'm getting attacked by the plant here as I move back and forth. What's the easiest way to do this call? So move the table or the plant? Probably the table, right? Yeah. Okay, so restricting on using the brackets and sending the column gives me a single column, converts this action to returns a series that is that column. Next, you'll see we're going to go in and we're going to get, instead of passing it a single field, we're going to pass it a standard Python list. So in this case, our df events brackets is kind of owned by Pandas, and then the brackets inside is really a Python kind of object, a list, a standard Python list. So Python also uses the square brackets. So I got the Pandas square brackets, and then I've got the Python list inside. And this will now restrict to these columns only. And again, I'm going to show you the first few rows. So, and here now I'm going to actually convert the output to a string, and then look at the first 3 characters of the string. So you saw earlier we did the same thing just up here. Now we're going to actually take the values out as strings and concatenate those strings, or actually slice. Thank you. Did I hear someone say slice? We're going to slice the first from 0 to 3 off of the string and take the first 3 characters out here. So again, we're just looking at getting, analyzing or observing the data that's inside the data frame. Here's another one that I use quite often, the value counts. Value counts essentially does, I think I actually mentioned this earlier, so maybe I cut that out. If you're a Unix person, it's a sort unique -c is value counts, or select column count star from database would be the SQL equivalent, and you get the value counts, which again are a Pandas series named game ID. So, and these are the number of events for each team these are actually for both teams for games that were played in this stadium, is the way this file is. This first column actually has a game ID, which has the home team. So across this row is information about both the home team and the visiting team, but the game ID is always defined by the location of the game and the date. So here we go, looking a bit closer. What do we got here? Oops. So I just did this to just kind of get you acquainted with this data a little bit more. But you see here, there's two consecutive events for the same batter, and we can use the Pandas lookup to actually get this row of data out. And I've talked about the series that has an index that's the column name. So here we go using the integer lookup. So essentially this says, give me row number 3, where the numbers are 0 to n in terms of the numbers of rows you have. And this now takes this row, it turns this around and into a Pandas series. So now we have a Pandas series. Its key is the column title, and its value is the data that was in that particular column. So, and I'm not going to do something on the side, but you could also go in and look at the series. I could say, look at the series and show me the lead off FL. I'm not quite sure even what that abbreviation means, but you could actually query the series and restrict the series down to a key that's in the series, and then subset the series out as well. Let's see.
Oh.
Yes.
Okay, question. So when you go from step to step, right, from step 3 to step 4, how does the data get from step 3 to step 4? Right? Is it all on disk, or is it in memory, or
yeah.
How does this stuff flow?
Well, this actually goes directly to a web server. The web server passes it to one of these kernels. In this case, the kernel is running Python, so we have an IPython kernel. Unfortunately, we missed a little diagram of that, but essentially we've got a kernel that's executing code and doing I/O. We've got a 0MQ messaging between the kernel and the web server, and we've got the web server serving up data to us. So when I hit the enter key, it sends this down that path to the web server, then queues it to the kernel, and the kernel responds back to the notebook server, and the results come back to me. So this is all essentially what I've done. I mean, this is all in RAM on my machine now. I pulled these files up from disk. I've got all these 191,000 rows in a data frame in RAM, and all I'm doing is going to IPython and saying, execute these commands and send me back the results. Is that answering again?
I just understand how the result of line 3 gets to line 4. If line 3 came back with a count of 6, and you needed it in line 4, how does line 4 get hold of that 6?
I'm not sure what you mean at all. You're saying how this input here, 102, becomes this output? Is that what you're asking me? No.
How that output, with your finger, I can't see it at all right now, how that output becomes available to the lines below.
It doesn't it does not.
So
It does not.
you can't, I think what you're asking is how do you pass data from cell to cell?
You could say it that way,
Yeah.
that's clear.
Yeah.
Are you able to do that?
Sure, because I could assign the this to, instead of just displaying it back, I could assign it to a variable.
And then use the variable.
And then use the variable further down. So this is kind of primitive exploratory sort of stuff, but in the real world you would be doing that. You would say, for instance, I could create a new object from any of these. I could create a new object as long as I just said variable equals, and it would create a new object coming back, as opposed to sending it to standard out, which is what it's doing now, essentially what it's doing now. I haven't given it a place to go, so it goes to standard out, and that tells the browser to display it. John?
Well, would it be fair to, like, the way I would answer that question is, it's stored in memory in the kernel, and then so if you didn't reboot the kernel, and it's still there, if the answers can be persisted in the file as output, they can be cleared, and they won't persist from session to session, presumably, if you have to reboot the server. And so it's just depending on the memory of that kernel.
Yeah, that's right, and essentially, this is a print statement. I mean, it is a print statement. Essentially, I've said, I'm interested in this thing, and the default thing is to execute the print statement and send me back the print. If I put it into a variable, I would end up, in this case, I would get a series back, a Pandas series back. So if I was and let's just do that. I'll just show, actually, we have done that right here, interestingly enough. Geez, I might have anticipated something like this. This type command actually tells you what the Python type of the return variable is. So in this case, I'm going to say what variable type is returned when I execute the value counts of the away team column in the DF events frame. And the answer is it's a Pandas series. And the default action when you call a Pandas series is to print its output to standard out. And so that's what gets captured. But yes, any of these things exist and can persist if we just assign them to a variable. Let's see. This also has an index. Okay, so this is now, we saw the value counts. Let's see. Let's just take the types off of here so we can see what the value counts look like again. This is the part where I told you where you edit the cells and you wish you hadn't. So that's the path I'm going down right now. So in this case, this is returning a series. We saw it return a series, and the series is keyed here, and the values are here. So I am going to say that the key is actually what we call the index. So down here, if I say, show me the index of this object, I get this index object back, and the index object is iterable. And you'll see me iterate that a little bit further down. But I think the point here is this is a fundamental Pandas structure, the series. And the series is essentially a set of keys and a set of values in a list. A data frame is essentially a set of series assembled, keyed on the row that they're assembled in. So let's see, we use value counts. So I did write this out. We've covered all of this. So here I'm going to create a few filters. So in this case, I am capturing the output. I'm capturing the output into a variable that I call filter homers. And I think I said a filter is not a defined Pandas term. But what we're going to get here, if we inspect the DF events column and ask it, is it equal to the event code HR? Remember we looked up, we had that key value, so this actually returns like 4 or something like that. So we're saying is, show me every row in this events frame, and I'm interested in whether the event code is equal to HR. And so when I run these, I now have set up these filters. So I can again now I'll inspect this. This, remember we said, is a Boolean. So we shouldn't get very many rows out here when we do value counts. So what we have here is 185,000 events that are not event code HR, and 6,105 of them that are HR. And they're, let's just look at, I should have mentioned some of these things earlier too. I'm just going to hit B on the keyboard while I'm in command mode, and that puts a cell in below where I was. Enter to come into to execute, and I'm just going to say filter homers, and this will do tabs for me. Dot head. Whoops. So you see what we get here. We've got 191,000 or some odd Booleans that are aligned with the data frame that tell me whether or not in that particular row event code is equal to HR. So I've set up some other filters here too. This is the game ID, which is the column that I showed you, that column that has the home team in it. Starts with Boston, or the away team is equal to Boston. There's an away team column in the data frame as well. So this is how I capture the Red Sox games. The ones that have Boston as the first three letters, or starts with BOS, or the away team is Boston. And I've built a similar one for the dreaded Yankees too, although they're not as dreaded as they were when I was doing this work. So that's how now I can, and you'll see, we'll see some of these in action a little bit later. So I'm going to just keep going here, and we'll see what the Red Sox filter looks like. We've got 12,900 Red Sox events and 178,000 that are not Red Sox events. And now I'm going to go through and go back to that index, and I'm going to iterate the index to make dictionaries, which is a standard Python data structure of these filters. I'm going to take the Pandas index, which is essentially the column names. It's an iterable, so I can put it into a for loop. I'm going to iterate through each of the values of that list, and then I'm going to go out and I'm going to populate I'll populate both of these dictionaries in a similar fashion to what you saw before. So the home team dictionary is going to be starts with team, and remember this was away team and home team, so the home batter ID is true. Essentially, that says these are the events that pertain to the home team. These are the events that pertain to the away teams. So, and this is all just going to run through in a standard Python loop. And it'll take a minute or so here. We're executing with the star, and now we've completed. We've gone through, essentially we've gone through, what have we done? We've gone through this 30 teams. So we've gone through this loop 30 times, and we've created two dictionary items in each loop. So now I have, I'm going to show you the top of the events file where the filter away team is Boston. So I'm going to come in here and pull out this particular, I think I need to explain this a little bit better. In my dictionary is now a set of, in the dictionary is a set of data frames. And I'm going to describe it here to you. So let's see. Is that an accurate way of saying it? This filter away team has the Boolean set of all of these. This is what I was trying to say earlier. This filter away team has the Booleans for all of the things that pertain to Boston. So now I apply that Boolean set. This is just a set of Booleans to DF events. and it pulls those things out that meet that filter criteria. So, and I've got one obviously now for every team here, so I can go back in here and change this to Detroit. And these are all the events that pertain to games in which Detroit participated.
So your away team is a series of toggles where the event at that index is part of the set now.
Say that again, I'm sorry?
So your away team is a series that indicates whether the event in all of the events is in that series or not.
Yeah, it's essentially, you said it right. It's a series of these Boolean true falses that say whether or not this particular row contains, the home ID and the home team is equal, as I've done here. So this is actually the away events. You'll notice the game ID is Anaheim. These away events are in Anaheim, and none of them are going to be in Detroit. They're going to be everywhere but Detroit. And this is the team ID, which will in this case always be Detroit. But so there are a couple of things that we got here. One that you hit upon, the Booleans. And this is the essence of filtering data in Pandas is these Booleans and bringing these Booleans together as an ands or ors. We've got a Python dictionary here that is storing each of these sets of Booleans. So I've got a dictionary now that's got, there's 30 teams. So each dictionary has 30 series, Pandas data series in it, each of the 30 pertaining to one of the 30 teams. So if you calculate the number of things that are actually, number of items that are in these dictionaries, there's 191,000. Do I have to divide by 2? I think I divide 191,000 by 2. No, I'm not even going to try to do that. There's a lot of stuff in there. There's a lot of Booleans in there. So yeah, there actually are for every one of those. There's 191,000 times 30. So we got a lot of stuff in there. And you can see this machine that's running them here is just dropped off the supported list. I can't put the new operating system on this machine. So this it's got a little bit of gray hair, just like me.
So could you, for input 113 there, can you put not away teams, and it would actually give you everything but the chart? Okay, cool.
Let's do this. So there you go. So there's the 3,100 that are, and then the other one is the 180,000 that are not. So on to something practical. Yeah, this is really practical, isn't it? So here's how I'm going to find out how many doubles the Red Sox had in 2017. I think I'm actually going to show not how many they had, but what were they. So I'm going to filter with the home team Boston or the away team Boston. And then I'm going to say the event code equals event code double. So this is going to tell me all those games that the Red Sox have participated in, and essentially it's going to make a Boolean for those games for those events in which the Red Sox had a double. And we'll see how many of those there were. There are 302 of them. So the Red Sox had 302 doubles in 2017. And if we run this next one, what we're going to do is do you see here I've used .shape. So this is the end of my DF events. This is my DF events output. And I've used .shape to tell me what, just give me a characteristic of it. Now I'm using the exact same thing here. And I'm using .head to show me the first few rows of it. So this is the first few rows, and if I say here, I'm going to say, again, this is the same thing that we've looked at, but this time, instead of getting the whole data frame out, we're only going to get the responsible backer ID out. And then instead of looking at the responsible backer ID, which would just be a list, just be a series of backer IDs, we're going to do a value count in it. So it's going to go through that list and it's going to tell us how many of each individual responsible batter ID accounts for these Boolean truths for Boston home or Boston away and Boston having doubles. So which is essentially going to put an identifying person on these. These are cryptically abbreviated, but Mookie Betts had 46 doubles in 2017. And I have not actually gone out anywhere else to validate this data, but it all seems reasonable to me, so I'm buying it. And this will be Keith Mullen will be next with 34, Bogarts at 32, Benintendi with 26, et cetera, et cetera, et cetera. The gone and also forgotten Manny Ramirez had 24. Hanley Ramirez, I should say. So that's kind of, I want to stop there because we've done a fair amount of digging. That was a very good observation to flip to negate that series and show and illustrate that. But any questions? Do we have a good, reasonable concept? We've got this data frame. We've got the way of selecting columns out of the data frame. We've got building Boolean series to restrict sets of data. We got combinations of Boolean series to further restrict and qualify the data that we're getting out. So any questions or comments or anything? I can keep going.
Yeah,
Behind you, John. One question.
You've been stepping through each cell, one at a time. I assume since I see run at the top there, can you run every cell?
Yeah, I can do this. I can. This is what they tell you shouldn't do in this kind of stuff. But I'm going to choose run all above. And we're actually going to go out. We're going to execute. We're going to rerun those data sets. You see it all popping out here? And we're back to where we started. And we'll see. I'm going to look for these cell numbers to change because we're going to get a point where I think I've already gone past that point. No, how many? All right, so here's where we were. So I reran everything above here, and we stopped here. And that ran through the whole thing again, created all those filters, pulled the data from disk, didn't compile anything. It extracted the data, it ran through everything that we did. And to generate those 191,000 rows and do the analysis on 191,000 rows, it just slapped through everything.
So if your data changed, then the results display change.
Yeah, which is I suppose can be a benefit and a detriment. This is why you would, for instance, want to preserve this as is, because I can preserve it with the data that's in it. But I can also, just by rerunning it or perhaps pointing it to a slightly different source, if it's an API, I can just refresh and get the data and run the analysis all over again just by pressing the button.
Okay. Second and final question. Can you export just the code? Like, let's say you want to export all the code and not the text.
Can you export just the code?
Yeah, I believe you can save it as a Python file.
Oh, you can.
Yeah, I've had some difficulties at times, but you think you can actually just pop it out? I mean, I haven't had the need to do it since way back when.
File, save as. It allows you to save as a regular Python file. Might not be save as. Might be a different option, but I do recall something.
Save as only. I don't know why it's not
Um,
popping up here, but it's
you know, I can guarantee you there are really good ways to get the code out. I struggled a little bit to get the code out at one point, and then didn't have to do it again, so I never came back to it, quite frankly. But there's got to be real good ways to get the code out.
Put it on for HTML files.
I will say this, and I just figured out a way to get the code out. If we actually look at one of these. this is essentially, not essentially, it's a JSON document. So any of the code that I have is in here. And with the proper stripping and identification of these, you can pull it right out of with JSON. And I've actually, you can see it, it's all in here. The contents, both the input and the output contents will be stored in this file. But if I choose to choose clear output, then in the file, all the outputs would be blank if we were to look in the source file. And this leads me to a bit of an aside as well, because let's see. I picked up this and started playing with it just a little bit. This actually is something called JQ, which is essentially a kind of a macro language for wrestling with JSON data. And this actually goes through and strips all of the output cells here. One of the disadvantages to working with notebooks is code control and the fact that that your file changes when you run it, even though the code hasn't changed. So this routine actually right here will strip the outputs out of the file. So that when I go to stuff it in the repository, I can put it back in the repository, I can strip it off, and I can diff it against the copy that's in my repository, and it'll be clean. So the best practice is, there's a number of people who have commented on this, to put this into your, right into your, forgot exactly what to call it, but in the, as you insert into GitHub, you can have, insert into Git, you can have run a process. Run the process of this, and it'll strip all the output out of the notebooks so that in your repository you can stuff just your input cells.
So to the answer to the question, the option is download as Python. So on file, you get a download as option at the bottom.
Oh, okay. There we go. Beautiful. That's a great question, and thank you for the answer, because now I'm learning. I hope you guys are too, but no, I definitely can say I'm learning. Okay, so and another one. Sorry, you got to try earlier, John. So I'm gonna put you last in the queue.
So this obviously seems better than Excel, but what scenarios would you use this over just working in SQL? A lot of the commands you were talking about here, it's like, oh, you could do this via, select star count.
Yeah. Well, I think that it really comes down to this notion of preservation and presentation. That you can actually that you're storing all of the code that you've used to generate, and I kind of see it as a real presentation tool. I also personally use it as a REPL, and have designed my workflow around using it just because it turns out to be, for me it was just a convenient mechanism of working. And in terms of instead of SQL or instead of Excel, Excel is just a mystery to me. Excel is a mystery. You got something that you got no idea. And also, I hear people around me saying, I got 100,000 rows. My Excel's falling over. Well, you're not going to have those kinds of issues. So I guess does that answer your question? Is that heading in the direction?
Yeah, so when you were talking about being able to pull data down from Salesforce or whatever, will you pull in the entire data set and then filter it on the Pandas side, or will you restrict your data set and then tweak it?
Well, if I'm smart, I will restrict my data set, but if I'm lazy, I won't.
And both can be successful.
Yeah, that's right.
Okay.
I've actually I've gone to Salesforce and pulled down 300,000 rows by 12, 15 columns, and you don't you can go to get a coffee. You don't have to go to lunch. You go to get a coffee, and the routines that I have here basically go back. We'll perhaps see these a little bit later. But keep going back to Salesforce. Salesforce gives you 2,000 rows, and then you learn how to get more. And you just sort of keep going until Salesforce gives you anywhere else. And then you build your data frame. And you got, at the end, you got your data frame for 300,000 rows. And now you can restrict down, you can do anything with that data frame. And you can even drop the lid and go home and keep working. Because you got the data, you got the whole data set and ran, and you pop the thing back open again, and you know, away you go. So that's kind of, you know, some of the little bit of tales from the trenches.
Cool. If I could just add to that question, so you can do a lot more data manipulation with Python code than you can with SQL in general. And then you can also do things that are a lot harder to do in SQL, like traversing schemas and connecting to multiple different databases. So just from a Python perspective, not even Jupyter notebooks, but Python pandas, there's a lot more you can do, more control on the data, and then it's very easy to take that process, organize it a little bit more, and create an entire application out of it. Right? So the beauty that I like about Jupyter notebooks is the discovery process, whereas if you don't know what you're working with, you can go through line by line and see how the data is responding to your code, and then you can start, you know, continue typing and doing that data analysis to the discovery stage.
Cool. Yeah, I think I'm glad you made that point, because I think one of the difficulties in the style of this presentation, if not the content, or just the subject, it's very broad, and it's not clear as to kind of when it's really a Python thing and when it's a Jupyter thing. But I'll tell you this, it's always a Python thing. Everything that's in there is Python. And the notebook is giving us a convenient method of viewing the input and the output, essentially. And all of these data extraction routines are all Pandas based, and that's a fabulous tool. It really is a great tool. So I apologize that it is kind of difficult to see these, but this is all Python in a convenient viewing and iteration environment, iterable environment. And John, you had another one, yeah?
Well, I guess it's more of, you sort of addressed it at a certain point, and it's more of like a riff than a question. But like, the big difference between, I love Excel, so we can, and there are pros and cons for sure, and you're totally right in your criticisms. But like, one of the advantages of Excel that, and I used to use mathematical notebooks a lot, and I don't really know, I guess the question is, does Jupyter have a better answer for this than Mathematica did? You know, this is really, outside of the scientific context and thinking about like real data sets, baseball, stuff that updates live from the server or from the database, you know, it's kind of this icky mix between code and data where like, and it's all intermingled. So you can rerun a line, which depends on all of the other lines that's run, and possibly whatever data sources it's pulling in, which may or may not have changed, the file has no idea. And like, one thing you can say about the way most people use Excel is that the file is the data and the code, and so it represents a snapshot of the world and everything I thought about of that world at that time. And it feels like you have to use a lot of conventions if you were sharing Jupyter notebooks around, right? Like, if you were like, oh, I have this Jupyter notebook reflecting the Q2 Salesforce blah blah blah, you know, it almost like you want to have a convention like, well, here's the part where I read in and read out from a file that exactly represents the set of variables I use to generate this report, because otherwise you won't be able to reproduce my work unless the inputs are frozen in some way. And then it's sort of like, well, then I better freeze the outputs too, or any of the manipulations I'm doing, because then otherwise I have to rerun the lines sequentially. Like, and you're like, okay, it's like the top line of the file is going to be some awful comment like, don't do anything first, rerun it from the top, or you know, something terrible like that. And I used to get into that trouble with Mathematica all the time. So I'm just like wondering, maybe, you know, Netflix's what's he what?
The paper mill.
Paper mill has some sort of like sanity controls for this, or maybe it's like you do have to have these awful conventions, or maybe the Jupyter community is going to move in some direction where it also has a concept of the data source, or like, you know, if you have you're going to export this to a PDF and it's going to reflect a printout and the story you wanted to tell. But to fulfill the promise of like, well, you can take the analysis from here and then go do some more crap. Like, you're going to need to be able to freeze the data, the kernel's memory at that time. So the question that was asked earlier. So I don't know. That's what scares me about Jupyter notebooks the most, I would say. And like, I've mentioned to you over the break, there's a commercial tool called Mode Analytics that is a very Panda-like
is well taken that, this is an evolving environment, and, there are tools in Python to preserve data, to snapshot your data and drop your data out. So it's all doable. Is it a little bit, how do I want to say, obtuse maybe at times? Yeah, I guess it is, and that's why I think I mentioned earlier, the strength and the weakness. There's a real strength
right
to
on what you said.
push the button and get the thing back, but it's also like, oh crap, it's this quarter's data and I wanted last quarter's data. And
Right. I was trying to make sure I could get last quarter's results, and I guess the question is, have you tried using this within a company or sharing these notebooks around? Have you run into any of those problems or solved them in some way?
It's no different than sending the wrong Excel file or having someone that doesn't have macros enabled and functionality not triggering. Every single type of mechanism has its own pitfalls. For example, one of the beauties of Jupyter notebooks like this is that you can save this and share it. And you can share it in a way that it's not editable, so it can't rerun if you don't want to, right?
Yeah.
Essentially, it's the equivalent of writing the code once and being able to point it to as many files as you want and have a flow that just kind of repeats. Similar to like when you rewrite a macro in Excel, and then you just refresh the data and you rerun the macro, except it's a lot more stable, like times 20s.
Oh yeah, I wouldn't use macros in Excel.
Spoken from a person who's written many macros in his lifetime.
Yeah.
And the data stays in Excel. I like this way better.
Yeah,
That's cool.
I agree. I guess I wouldn't be here if I didn't agree, so thank you. But
do you find that as business analyst level folks in technical sophistication are comfortable looking at a Jupyter report? Because they might want to then go paste that into Excel to think, because they might not be comfortable with that.
It's all the means to an end, whoever likes what. I've seen people that after you create an Excel report or you create Pandas report or I saw he imported Matplotlib that allows you to do graphs and all those cool things, and then you can display all the graphs right there in the Jupyter notebook.
Which is awesome.
I've seen a lot of people then take all that, screenshot it, and put it in a PowerPoint.
Right.
So I mean, I can't answer that question. People will consume what they want to consume, how they want to consume.
Cool. That's a good answer.
yeah, this is just kind of an endless. We could have a lot of discussions around this sort of stuff. Anything else before I see if I can poke along a little bit further? How much more time do we have?
Well, good job. Any questions?
Nobody's fallen asleep yet? All right, so let me pick up the pace just a little bit more. I only have a few things left here, and I'm just going to touch on them lightly. But one certainly is merging data sets, and we talked about SQL before. Pandas does a fabulous job at merging data sets. So let me follow my script here, otherwise I'll probably confuse you more than I will enlighten you. But here are the Red Sox doubles. And merge, we're going to merge. And so merge requires, I got a series here with just the responsible batter ID. And I've also got a data frame, the whole thing. So these are identical rows. This has many columns and is a data frame. This is the single column and it's a series. I'm going to merge, and merge is a data frame method. So I'm going to have to use the data frame. So, and a data frame, by the way, if I was to have, actually, if I put two brackets around here and made this a list of one item, I get a data frame, not a series. But obviously, if I had another set of brackets and more than one field in there, that would be a data frame. So, so I'm going to look at the players here. So here's the player file. It's got the ID that's in the event file, and then it describes the player and when he started. And in this is interesting, just in the first few rows here, Tommy Aaron, who is Hank Aaron's brother, by the way, for baseball folks, he was a player and he played his first game in April '62. He was also a coach, And so that's in this particular file of the players, and the umpires are in this file as well. So that's a bit of an aside, certainly. So here's the set of codes that we saw this earlier. This is the coded players, and here now I'm doing a join. So I've got my set up in here. These first two lines, I've got the set that we're familiar with, which is the set of doubles, and I'm merging it with the players that we just saw just a moment ago with Tommy Aaron in. Left, which is in this case events, which is the outer frame here. So left on responsible batter ID, right on ID. So right is the second one, that would be the DF players. And then I'm going to output the last name from that, just the last name, and do the value counts. So this goes back in and now joins, and now I'm looking at the result of the join from the player side and getting the player's name here, actually the player's name instead of the code. Cool and everything, you know, we've probably, most of us seen this before, but there are a couple of other parameters here that, okay, yeah, so here we go. This actually doesn't do what I was expecting, but I put another parameter in here. So I got validate many to one. So what this does is instead, and I can't tell you how many times I've done joins in SQL Server and not had the same, you know, not had exactly what I thought I had and joined them together on lost rows and, you know, all those kinds of things. You can do a validation and you get a many to one validation in this case, and it will actually generate an error, generate a Python error and tell you you do not have a many to one relationship. There are you know, values on one side that don't satisfy what you're after, and there's a number of validates. We've got one to one, many to one. I think there's a many to many. There's also another parameter that I can add, and that is source. And when you add source, if you're doing an outer join, it'll tell you that your source, you know, that it appears in the left, the right, or both. So you'll actually get a column then in your data frame that allows you to understand the source data frames and which one or ones did not have the data you were looking for. Just by going in and applying filters on that column, then you get the set of rows that's only on the left side or the set of rows that's only on the right side. Is that kind of hitting home? It's a real world thing that I have been able to put to good use. So that's the join and these extra parameters of validate and source. Pandas is really good, and I'm most of the stuff I do, I use it for is kind of munging data and bringing data sets together and ensuring that, you know, that what's over here is over there. I'm not a data analyst, a true data analyst, but some of the real powerful things with Pandas are grouping and aggregation. And anyone who does R, it has a similar philosophy of I forget what they call it. They call it group, count, analyze. There's three pieces to it, but I'm just going to show you. Let's see what we got here. So this is the group. So I've got a group hits that where I'm going to actually group by these two columns, the respondent ID and the event is in any of these event codes. So this is a Pandas function, is in. So essentially anything that's in this list will return true, and spit out the results for us. So here we are grouped on player and event, and it counts for this player. He had 20. He had 107 event code 20, 43 event code 21, et cetera, et cetera. So this is just, you know, just to show you some of the basic grouping pieces here. And let's see, where else are we here? Crosstab. I'm going to make a crosstab here. The respondent batter ID is going to be the rows, and the events are going to be the columns, and we'll see what we get. So, this is the Pandas crosstab. I'm passing it a data frame. I'm passing it two slices actually, two series here. And then it's going to crosstab those two series against each other. So these are the players now. And these are these coded event codes that I actually translated back. If you remember, I happen to know 23 is home run. So this guy, Abreu, had 33 home runs, and one of the Adams family had 20 home runs. So that's a simple and straightforward crosstab, one of the aggregate commands. And then I may have come down here, and I don't think there's anything here that's dramatic. Here's another crosstab, but in this case we've done a few more restrictions. We've actually, again, it's the same notion of a crosstab. And if we look closely, we'll see that I've got a comma here. So this would be one side of the crosstab, and this would be another side of the crosstab after the comma. So I've done restrictions on the columns here, essentially. And then, have I done restrictions on the rows too? I haven't, but I've done restrictions on the columns. And then I've actually done, at the end, I've done sort by value 23, which is the home runs. So this essentially now is a crosstab that stacks up. At the top of the list is the player with the most home runs, and this is the number of triples that player had, doubles and singles. So that's what this crosstab has pulled out, and tells you that Giancarlo Stanton had 59 homers, and Andrew Judge had 52, and JD Martinez 45. And I went through and applied my the join that I did before to putting the players in, and it turned out that Davis had the most home runs because there's 17 Davises, and I joined them all together when I did this crosstab, so I dropped that out, and we're going to have to read through these codes because I didn't want to go through and get something more sophisticated. But essentially, all I'm doing here is I'm sort of restricting and changing the sets of data that I'm feeding in to come up with this crosstab, and then I'm ordering the results as well once I get out with a sort by. Okay, so let me switch over here. And I will show you a few things here using an API. So these are my libraries that I'm bringing in. Here I'm going to essentially access Salesforce. These are a couple of constants that I'm going to use. These are Salesforce object IDs. And I'm using something called .env, Python-.env is the module that I'm using here. And what it does is it allows you to, it reads a file off disk and allows you to store things in the environment. So I can call from the environment these credentials, essentially. These credentials are stored on disk. They're stored in a hidden file. That's, they're stored just like a key, so you store them just like you would your private key in terms of the restriction on your machine. So that's how these credentials are stored. And then they're read, and I can actually read them. They're fed into the environment by data-env, and then I've pulled them out of the environment using this config class that I built. And this is giving me values that are in my environment. So let's see. This is requests. I don't know if you guys are Python people at all. There's one of the most downloaded Python module is requests. which essentially allows your Python to be a browser. So at the other end, you know, they think you're a browser. It manages cookies, it manages sessions, it manages a whole bunch of stuff, and makes that transparent to the user. So I've got a session. I think that shouldn't take very far. Very long, rather. That's a bit discouraging. This didn't import properly. It says I'm not connected. All right, so let's see if we can refresh here. Yeah, it should be open. All right, so does it say All right, much better. Okay, so here we are. I'm actually going out now to Salesforce, and I'm passing it these things that I pulled from the environment. And now I have a session that is open that has essentially, I've logged into Salesforce. Salesforce kind of thinks I'm a browser now at this point. And I'm going to show you this little report here that's just a standard report that I might look at on a regular basis. I just want to show you this so that you can see what we've got here is just a standard report with 28 rows out of Salesforce. But if I come back in here, and I'm going to take that, you see that report ID, I've actually put it in a variable up above, but this report ID is in this variable. So now what I'm going to go do is I'm going to go and use the requests, and I'm going to request this report via HTTP. So I now have a response object that has the output of this cell that I just ran, which essentially says download this report in UTF-8 as a CSV. So now when I'm going to read the data from that response, the response has a text property, and I'm going to call the text property, pass it through this IO string, which is going to make Pandas essentially think it's reading a CSV off disk, and it's going to pull that report into a Pandas data frame. So now we've got this report. This report actually has 33. We had 28 rows before. That's because the last 5 rows are a report footer. I'm going to lop the 5 rows off like this. And now I end up with 28 rows by 12 columns, which is, whoops. If we were to go and do counting, I keep losing my mouse. Precisely the same as what we have here. So now I have this Salesforce report in an object that I can do whatever I want. I can filter, I can do whatever I want. And so essentially, you know, this is something that you know, I saw people doing, and I'd done more than a bit of this myself. Go into Salesforce, run the report, save as CSV, go to Excel, do file open, point it to the CSV, and open the file. That's those steps are what we've gone through, but now we've got it in a Pandas object. No sense in rerunning it. All right, so here's a little bit more of a interesting, I think, exploration. In this case, I'm going to go in to get what we call these event masters, which are essentially part of a Salesforce model in which we have events and we've got event details. So I'm going to say, get me the event masters, and I'm passing this in to the code that I've written that is going to execute this and return what's in Pandas called a tuple, which is an immutable set of values, and it's going to return the data frame of these events. and it's going to return the count of the events as well, which I got for free, so I might as well take it. The first response you get back from Salesforce tells you how many rows are in your response. 2,000 rows, and a URL for more is what you get back. So I grabbed that off the first set, and so now I come in and I've got, these are the columns that I've retrieved. These are the values that are in here. There's about 214 rows in this particular one. These are this is the type of event that we have here. And for the guys that work with me, this is all anonymized data. There's no user data in here, but these are part of our historic anonymized set. And so now, so what I'm going to do here now, how should I divide this up? I'm going to be very plain. When you see one of these, like vpu.get, this is code that I've written. But all it does is it creates SOAPL, what they call SOAPL, which is Salesforce kind of query language, and runs those commands and hands them back here. So in this case, what I'm doing though is I'm going to go in and I'm going to pass this function a list that I built from df events, passing a Boolean or creating a Boolean of event type equals biometric. And this is going to just pull back those rows that are in this 134 and then pass them in to this next function that says, okay, now give me the details that are associated with these 134 rows in the initial set that I brought back. And I was going to do some plotting with this stuff, but I didn't get far enough. But so we're approaching the conclusions here. So we've gone back out, we're running that, and I got 4,006 rows back from Salesforce now. So this is basically just coming in and looking at my, it's looking at the same thing. What I wanted to see was, are there any duplicates here? So if I do set, then that will dedupe by converting into a Python set, and then length of the set just tells me the number of entries that are in it. So let's see what we got here. This is the columns that are in this set. This is the systolic and diastolic columns for the first half a dozen rows, 5 rows. And now I'm going to come in and do something, a categorization. So I've got a list of labels, then I've got a set of bins, and I'm going to be able, what it's going to do is it's going to apply those between 80 and 100 to this, between 135 to this, and between 135 and 20 to this. So I'm going to get my data categorized now. So these are my categories. Again, this is a series coming out. So now we're looking at the I think it's systolic that I had here. And this row is somewhere between 80 and 100. I'm sorry, between 100 and 135. This row 4 is somewhere between 135 and 120. So I've categorized now the data in that column. And then we can go out and plot and do things like that, which I didn't have time to do here. So I think that gets us to the end. I hope you guys have learned a little bit and are somewhat inspired by this. This is I think it's here for good. Something may, how it is in these things. I mean, something may come along that is new and cool and replaces it. But I think the concept is really here to stay. And these guys have a pretty good head start. They got a Nobel Prize winner running around saying how cool it is now, and they've been funded by a 503c for these tools. So there's a lot of things that are supporting this environment. So I think it's going to stay for the long term.
Thank you.
Anything else?
So yeah, first of all, thank you. Thank you all for coming. We do have a GitHub repo for anyone who wants to take a look at this, right?
Yeah.
So we'll post that on the Meetup page. And again, just thank you very much.
Yeah, thank you. Thank you, folks.
Oh, one more thing. If you guys ever want to do a talk like what you did today, reach out at the channel. We do usually offer like twice a year, open to the public. Drop a proposal and let us know.
Yeah, I hope you guys come back because Carlos has put some interesting things together.